Part 4, negative exponents and radicals. Negative exponents do not make numbers negative. Okay, complete the following table, okay, by typing the powers into your calculator. So 2 to the 0 is just 1. In fact, anything to the 0 is just 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4 is 16. 2 to the 5th, 32. And 2 to the 6th is 64. Okay, what's the pattern? Well, you can see that this pattern is multiplying the previous number by 2. So everything goes up by 2. Okay? So now we're going to complete the following table with the negative exponents. So you're going to get a decimal. Some of your calculators might be set to make it as a fraction as it is. It's the fraction that's important. Okay? If your calculator gives it to you as a decimal, just use that math frac or math number menu approximate to fraction for the TI Inspire users. Okay, use that trick that we learned last section to make your decimals into fractions. Okay, so 2 to the 1, or 2 to the 0 is just 1, which is, of course, just 1. Okay, that's the fraction. So 2 to the negative 1 is 0.5, or 1/2. Okay, 2 to the negative 2 is 0.25, which is 1/4. Okay, this is 0.125, which is 1/8. Okay, this next one 0.0625, which is 1/16. 0.03125, which is 1/32, and the last one 0.015625, which is 1/64. Okay, so what does that table show? So the table above quite clearly shows that none of those numbers are negative. Okay, so the negative exponent does not make negative numbers. What the table does show, though, is that the negative exponent simply takes the reciprocal of the base. So check this out. 2 to the 1. Here, I'm going to write in red so you guys can kind of follow along where I'm looking. So 2 to the 1 is 2. Okay, 2 to the negative 1 is 1/2. Okay, 2 to the 2 is 4. 2 to the negative 2 is 1/4. 2 to the 3 is 8. 2 to the negative 3 is 1/8. Okay, so this brings us to our powers of negative exponents. Okay, when x is any non-zero number and n is a rational number, x to the negative n is the reciprocal of x to the n. So x to the negative n is simply, because that's written over 1, so you just flip the two numbers. So that's just 1 over x to the positive n. Okay, if we have a negative exponent on the bottom of a fraction, he just flips up to the top. So 1 over x to the negative n is the same as x to the positive n. And remember, this is so long as x is not equal to 0. Okay, because remember, in a fraction, you are never, ever allowed to divide by 0. So that's just, we have to say that. It's not like you're ever going to get a question that has the 0 in it, but you just need to be aware. Okay, so evaluate each power. So we just learned that 7 to the negative 2 is just 1 over 7 to the positive 2. Well, 7 squared is 49, so this is just 1 over 49. Awesome. Okay, what about when we have a fraction, so this 10/3? Okay, so really what ends up happening here is this, that the fraction flips. So this is going to be 3 over 10 to the positive 3. The negative just flips the fraction, and then 3 cubed is 27, and 10 cubed is 1,000. So there's our fraction for that guy. Okay, and the negative 1.5 to the negative 3. Okay, so that is 1 over negative 1.5 times negative 1.5 times negative 1.5. Either way, it works out to negative 0.296. Okay, awesome. Okay, So we can apply the meaning of rational exponents and negative exponents to evaluate powers with negative fractional exponents, negative rational exponents. For example, the rational exponent in the power 8 to the negative 2/3 indicates that these operations to the right. Okay, so here the 2 is an exponent. Okay, so really we're gonna square 8. Okay, so in this case it's a square. This guy, he's the radical. So this is signifying a cube root. Okay, and then this negative sign, that negative sign is the reciprocal. Okay, so there's 3 math operations going on here. There's a reciprocal of the base, so this is going to be 1/8 to the 2/3. So we're going to square this, so that's going to be square, square. Okay, so that's going to be 1/64, okay, to the cube root, which is just 1/4. Okay, again, not a huge deal, but okay, since the exponent negative 2/3 is simply -1 times 1/3 times 2, and order does not matter when we multiply, so we can apply these 3 operations, the reciprocal, cube root, and square, in any order. See, that one I did the reciprocal first, then the square, then the cube root. What if I did the cube root first? So the cube root of 8 is 2. So that's going to be 2 to the negative 2. Okay, well then I can go 2 squared is 4, so I'd be 2 squared to the negative 1. So that's 4 to the negative 1, which is just 1/4. So I totally messed up the order, and I still got 1/4. Okay, and that just works that way. It's perfect. Okay, so evaluate each power without using a calculator. Now again, on a test or an assessment, I'm never going to ask you that. But for now, let's just practice these things. Remember, I kind of said before that it's always best to do the root first. So that 3 represents a root, so that's going to be cube root of 8, okay, to the negative 2. So the cube root of 8 is just 2. So that's going to be 2 to the negative 2. Okay, so that's just going to be 1/2 squared, or just 1/4. Awesome, easy. Okay, again, we're going to do the root first here. So that's going to be the square root of 9/16. Okay, so the square root of 9/16, so that's just 3/4, okay, to the negative 3. So the negative just flips the fraction, so that's going to be 4/3 to the positive 3, and then 4 cubed is 64, 3 squared is 27, and there's your final answer. If you do type this into your calculator, 9/16 to the negative 3/2, okay, you would actually put that in brackets. So you'd go, oops, sorry, my bad. So you would go bracket 9 divided by 16, close the bracket, little hat guy, -3/2. So type that in, and you would get 64/27. If it gives you a decimal, go math frac or menu number approximate to fraction, enter, and then you would get the 64/27. Awesome. Okay, last little bit. Okay, example 3, applying negative exponents. So paleontologists use measurements from fossilized dinosaur tracks and this formula, okay, to determine the speed at which the dinosaur traveled. In the formula, v is the speed in meters per second. Okay, s is the distance between successive footprints of the same foot, and f is the foot length in meters. Okay, use the measurements in the diagram to estimate the speed of the dinosaur. So v equals 0.155. Now in this equation, s is 1 meter, so we get 1.00 to the 5/3. Okay, and then our f is 0.25. And that is to the negative 7/6. You just type this into your calculator as is, and you get 0.78 meters per second. So that is how fast the dinosaur moved. Okay, so that is it for this part. I need you to practice this section 4.5 in your textbook. Starting on page 233, do those questions. Make sure you show your teacher when you're done, and we'll see you next part. Okay, thanks. Bye.